So hey, I'm back with more scary stories. We spent a lot of time thinking about this, and so that's why I'm spending more time telling you about it. I just wanted to kind of recap, obviously, we saw all this. I think this is the more interesting thing to talk about, which is being aware of the types of attacks that are happening today, and how do we as an industry and as the people in the room who are vendors, how do we as vendors, and people in the room who are customers, how do you as customers get yourself in a better kind of identity security posture? And so I just want to talk a little bit about some of the things that are happening here. There's been a real shift in the attack surface, I'd say, in the last 2 years or so, right? And most people don't know this, but so usually when you see an attack published in the news, you hear about how FireEye showed up to go help that company. In general, actually, a Microsoft team shows up as well. We don't get publicized near as much. But one of Microsoft Consulting's largest single businesses is helping customers recover from these kinds of attacks. And of course, we write all those up and use those in our internal knowledge base so we can figure out how to make the product better and how to help protect more customers. But one of the things that we see here is that attackers today will get into your corporation using some kind of low privileged account, right? And then over a very long period, in fact, in some cases, multiple years. In fact, I hate to say it, at Microsoft we had one attack which internal to our network, which we didn't find for many, many years, right? Where someone had gotten into the network and looked like a regular user, and they were doing things that without really special and really precise views, you couldn't find that it looked different than a normal user, because it was a normal user account and they were using some normal machines. But they were building up kind of this arsenal of weapons on the machine, and then using that arsenal to move sideways through the corporation and find ways to harvest credentials of higher privileged users. And this is a very typical attack pattern now. Find a user with higher privileged credentials and then use that to move further to more machines with even higher privileged credentials. And in fact, if you look at most of the major attacks recently, you would find that one of two things happened. Either a senior executive got phished, like that one's pretty common. A senior executive gets phished easily. Unfortunately, sometimes very easily, or someone took a low privileged account and managed to escalate it. And they sit in your network for a long, long time, watching what's going on and kind of hiding out from detection. And so that's a technique that's used very frequently on premises, and it was kind of almost perfected online, as I was telling you about for the case of one of our customers who got caught by the attackers. He had no idea there was an attack going on because they were very stealthy about it. And for many, many days and months, the attackers just built up enough information until they could finally really go and execute what they had wanted to. So you have to think about how to protect yourself from these kinds of things differently. And I thought it might be interesting to talk about some of the things that we do and I think are kind of table stakes for that, and some of the more advanced things that are happening as well, and share some of those with you as you're thinking about how to protect yourselves. In all of these cases, a lot of these are great things. Now, hopefully, let's start with who has some kind of multi-factor authentication system turned on? Okay. How many of those are based on an oath code? Okay. So I would say, first of all, that's the first weak link that you might want to go back and think about how you get rid of. Unfortunately, we know a number of cases now where, particularly this is the one that seems to get senior executives, where a senior executive gets phished by some kind of man-in-the-middle attack, turns over an oath code, because it looks like they're logging into Hotmail or Google or something like that, and then the criminals take the oath code, quickly replay it. So they build entire websites that just take oath codes, replay them, and then scrape everything out of your mailbox. Right? So for instance, we know of one customer who their CEO, the attack started with his son's iPhone, and they found the CEO's email address from the iPhone, and then they sent him a piece of personal mail that directed him to go, from a friend, so it was from a friend of his, they sent a piece of personal mail that directed him to go and check out some things that they'd been discussing together. And that sent him to a page that looked an awful lot like logging into his normal mail. He put in his oath code, and they very quickly, in fact, with a completely automated system, scraped everything out of his mailbox, including all of his banking information about how to reset his passwords on various accounts, all kinds of things like that. So one thing I would say, first of all, is that if you've got oath codes in use, you might want to think about other things that don't allow, like something that requires a second path or that can't easily be replayed for use. But first of all, just getting some kind of credential hardening in place is a big first step. At least you've made yourself, if it's like the joke, I don't have to outrun the bear, I just have to outrun you, right? At least you've made yourself the person who's faster if you've put in, if you've got some kind of multi-factor auth in. The second is to really think about attack intelligence. Some of you are large enough companies that you could do your own attack intelligence. Some of you will want to have, use a partner or a vendor to do attack intelligence for you. But if you're not looking at the kinds of attacks that are happening, or at least have a vendor or a partner who helps you with the kinds of attacks that are attacking, you're probably behind the curve a little bit. So it's definitely something to get involved with and think about. I think the most promising, interesting area right now, as I was saying earlier, is in this area of advanced detection, though, where instead of just looking at known attacks, you look at things that are uncommon attacks and then uncommon usage patterns. And I'll talk a lot about that later. And then finally, dynamic mitigation, I think, is just we're all getting there, but we need to get there very quickly. Like, how do you make sure that you're doing continuous authentication? And I liked Andre's piece about kind of accumulating little bits of trust and managing away little bits of trust. Like for us, one of the interesting things, like we think about your password as just one of 80 plus attributes that we evaluate when you log in, and not the most important one, right? So your password is an interesting thing to get into the Microsoft account system, but if another 50 or so attributes don't line up, we don't care what your password was, we're not letting you in. And we do this all the time. Like we do it, in fact, that's one of the number one things that happens when we see attacks is almost every user credential you can imagine has been leaked somewhere, and you can purchase it online somewhere. So we spend a lot of time worrying about all the other attributes around an identity. What device are they on? Where are they coming from? What kind of device is it? What kind of browser did they use? We're doing some really interesting investigations into typing patterns, and well, Alex always uses a tab when he moves between things, and someone else always uses a mouse. So there's a lot of additional context you want to take into account when you're thinking about the mitigations and who you let in. So I thought I'd just start with some of the interesting ones. Oh, this is an old version of the deck. Oh, well. Hey, we'll go through it in a slightly different order. I'm going to talk about this. So this is an area I think is the most exciting set of stuff, so I'm going to save it for a little bit later. But essentially, if you imagine this had a different title on it, the first piece of work I think all of us need to do is start getting signal, right? Like watching things very closely, and you can't do this in any way except for very large data sets, probably in the cloud somewhere, because you just can't get enough computing power on premise to do it. So for us, this means we take all of our data that we get from the Microsoft account system, from Office 365, from Xbox, data that we buy online, data that we source from other vendors, data that we find on premises, and we start pumping it all. In fact, we do this today every day. We pump this all into our machine learning systems so that we can start developing models and watching and seeing what things are happening in the world that we need to be aware of. There's some really common ones that are easy to start stopping, and in fact, this will take care of a lot of the basic problems, right? Like brute force attacks. Those are super easy to see. But one of the things you want to do, for instance, is you want to make sure that when you're stopping a brute force attack, you don't let the vendor know you don't let the attacker know you caught them. You just make it look like they got the wrong username and password, even if it was the right username and password. Another one that's really common, we see this a lot, and I think it's one of the advantages that cloud services had is we have visibility across a whole ton of customers. We have visibility, like I was saying, across 500 million active consumers and another 5.5 million businesses. So we can see things like this happening as well, where we can see individual IP addresses that are trying to log in as lots of different people against lots of different businesses or consumers, and be able to stop them before they get to the green part here. And this is an area we would really love to do more data sharing in with other companies, is essentially setting up exchanges of known bad IP addresses so that in real time we can all be protecting each other and our shared customers. Another one that's really useful, so our Microsoft's Digital Crimes Unit helps us with this. which is they watch a whole bunch of different Tor sites for us. And our digital crimes unit does all kinds of other things for themselves. But one of the things they do is they watch Tor sites because that's where a lot of the bad stuff is happening. And they feed all the data into our system for us so that we know that, oh, these IP addresses are all coming from an anonymizer. And this is a very traditional attack pattern now, it turns out. So for instance, we know that recently there was a set of attacks that got past almost everybody's geolocation sensors, and I'll talk about that in a minute, but the impossible travel kind of algorithms that say, well, you couldn't be in Texas and in London at the same time. And it turns out that online you can go buy a VPN connection in Texas and make it look like you were in Texas. All right? But if you've got a good set of data on where the anonymizers and where those anonymizer VPN points are, then hey, you can track those things as well. So we need to get these kinds of data into, like I was saying, these IP exchange pools where we can all share on who are the bad actors and what are they doing. Botnets is another one. So this is Microsoft's Trustworthy Computing team. You guys may have heard of them. And our digital crimes unit together collaborate on taking down giant sets of botnets. Right? And we're not the only players in this. There's lots of players in this business of essentially watching botnets and then figuring out how do you cut off the command and control center. But that takes a long time, and there's a lot of investigation that goes into figuring out the command and control center in the full breadth before you take it down. But this is a great source of security information. And again, we feed this into our cloud so that we know that if there's a login coming from one of those, we can usually tell you, oh, hey, that's a known botted machine, and we can even tell you what it's infected with and what to do about it. Again, I'm using this as an illustration of the kinds of data and kinds of data exchange that we'd be we're enthusiastic on sharing with people. This is one of our most recent pieces that we've just added into Azure Active Directory. So this is through various means, working with the federal government, working with other governments, working with some known actors. We acquire sets of user credentials that have been leaked. Like this should just be a best practice, I think, in the industry, which is check all of the known leaked usernames and passwords and shut them off, right? So in this case, if you're an Azure Active Directory customer, we can show you all of the credentials in your company that have shown up somewhere that we've been able to acquire and let you shut off those accounts, right? So it's another kind of information sharing we really need to get good at across the industry. And there's a lot of really cool work here already between kind of the big internet providers, but we need to both increase the depth of data and the breadth of data that we're sharing for these kinds of things. The other one, which is just kind of basic stuff, and if you're interested, we can even give you products to help with this, is making sure that it's finding all the weak links in your security chain. As I was saying in the case of the telephone takeover, you're no better than your worst, weakest link, right? So you might beef up the whole thing, and it's kind of the same point that Andre was making. If the trust root or your cert root is bad, it doesn't matter how much you beef up all the rest of it. So you really do have to think about things like, hey, where do I have these vulnerabilities? So for instance, in your on-premise Active Directory, with our new advanced threat analytics product, we can show you, oh, here's all the places that there are weak links inside of your corporate firewall. Right? In fact, we deployed this at Microsoft and found in the last 3 months 18 different potential issues, 10 of which were valid configuration problems. And we're the guys who know how to configure all this stuff. Right? So it's another area to really think about. As you're thinking about your strategy for how do you protect yourself in this crazy world of attacks, making sure that you can identify and find all the weak links and get them fixed is a great thing. But that leads me into the... Oh yeah, this is just another one. I apologize. This set of the deck is slightly out of order. There's all kinds of malicious attacks that happen on-premise. Patch the ticket, pass the hash, overpass the hash, brute force, golden ticket passes, all kinds of just nightmarish things that people have learned how to do. So you'll be happy to learn that in Windows 10, we've done a whole bunch of work to harden against these. So for instance, it's really hard now in Windows 10 because we've put the TGTs into protected memory. So it's pretty hard for a criminal to get those and do anything with them. However, if you're not going to Windows 10 soon, or you've got, obviously, like every company in the whole world, you've got an enterprise full of all kinds of things. We can help you with this as well if you're interested, which is just being able to, like at the bottom here, I'm showing how This is a sensor that in our advanced threat analytics where it can show you that, oh, for some reason, someone just tried to use a pass the hash from a machine that hash wasn't originally given out to. Right? So we can see this kind of traversing across machines in the network and warn you about it and give you recommendations on how to fix that. But I think the most interesting set of work is this in the area of abnormal behaviors. This is, instead of looking for the attack, this is just the opposite, which is looking for the thing that's different from normal. And I love the work that's going on here. A bunch of this is happening in the security industry, a bunch of this is happening in the identity industry. And I think it's an area that's ripe for getting us ready for a scarier future. And the basic techniques here are the same, but there's a lot of interesting exploration going on. The basic technique is, look, build up an entity graph, right? Like all of the different things that interact with your identity system, all of the users, all of the devices that they work on, all of the services that they use, all of the resources that they access, build up that identity graph, and then start watching the things that those identities do with each other, right? That those entities do with each other. In fact, Forrester has a really interesting set of new reports on this whole area that I think are fabulous. And you can see very quickly over time things like abnormal behaviors. So for instance, for me as an entity, right, me as a user, if you saw me come in and you saw me log in every morning at about 7:30, and I used about 6 apps during the day, and I logged out finally, and there was no more activity for me after about 9:30 at night, you'd be like, oh, well, that's Alex. That's pretty normal, right? But if all of a sudden you see me logging in at 3 a.m. in the morning, and I'm trying to access 35 apps that I never accessed before, right? Then you want algorithms that catch that and say, oh, well, hold on, something weird's happening, and take automated action against it. And we do this both in the cloud and on premise. In fact, our newest set of algorithms in the cloud, which we think are pretty interesting in this area. And it's not just us, like we know that in fact, we compare notes with our friends at Facebook and Google and a bunch of other big companies. A lot of people are working in this area, and I think it's the most fruitful and interesting, which is that idea that you can use these big, huge data lakes and pools of information with really smart cloud computing to be able to get visibility into things you never could before and develop these very sophisticated models that are sensitive to differentiation from normal rather than for looking for specific patterns. And this is much harder for an attacker to get around than it is if they know the specific pattern you're looking for. In fact, in this case, we can even see, so if you saw me during the day, I'm logged in, and then all of a sudden I'm logging in from a different device in a weird look, nearby, or I'm logging in and trying to use lots of different applications that I don't normally use, all of those things can be triggers that then set off the right set of adaptive behaviors, either warning an administrator or locking out an account or resetting a password or requiring an additional factor of authentication. I think this is the most promising, interesting area. And particularly there isn't as much of this going on yet in the enterprise identity area. We'd like to encourage more people to get engaged with us on it. But in the cloud consumer area, there's lots of cool stuff here that I think we can bring to bear on the enterprise space as well. So again, this is more of a request for shared IP, and we would love to work with anyone on just how we get good at this kind of anomaly detection. And even if we're not sharing the intellectual property, at least sharing information about accounts that are displaying strange behavior so that if it's showing strange behavior in a Microsoft system, maybe we can use that to help protect that in another system because we're all interlocked in this security fabric that we have to make sure we're protecting. Yeah, yes, in fact, that's exactly what we'd like to do, is make sure that it can be used. Well, so for instance, in the cloud today, it extends across way more than Microsoft directories. On-premise, we'd like to be able to do the same thing. If you're interested in any of this, you want to check it out, you could go get a free trial of Azure AD and see it at work right away. We also have our advanced threat analytics product is in preview right now. You can get this for free and download it as well. We've deployed this or begun the deployment of this at Microsoft, and even with a small number of domains and not even our entire first forest, we're seeing lots of things we need to go work on. And like I said, that's in the company where we invented the damn thing and we know how to configure these things correctly. And that's my story. So again, it's just I would go back to the same, I don't have the slide here because it's out of order, unfortunately. But I would just go back to the same request we had earlier, which is we'd love to work with more people, get the industry moving more quickly on how we get ready for the future of the Internet of Things and security, and how we can help you as both partners and customers secure your, in a world where you should assume breach, basically. There's only two kinds of companies in the world today, those that know they've been breached and those that don't know they've been breached. So we'd love to help both as an industry and as a company, customers who have those kinds of problems. Right? All right, thank you for your time.
You mentioned about not letting the bad guys know that you detected that they're trying to get in. What are some of the things you're doing with that information when you know you've got a bad actor that's trying to access the system and you're letting him try?
Well, so it's a great question. How do you? It's kind of like what's the jujitsu against the bad guys, right?
Yeah, exactly.
Yeah.
What's your counter?
Well, so there's a couple of different things that we see that are fruitful. The first one we always try to do is don't let the bad guy know any more information than they came in with, right? So if a bad guy comes in and and it's very clear that you block them from logging in, rather than just making it look like they had a bad username and password, they just left smarter, right? Whereas if they log in with a good username and password and we block them and it looks like it was a bad username and password, well, they just found out that they just got disinformation. Right, so we try to find as many places as we can where we do those kinds of things. But then in the on-premise world, it's even more interesting, right? Because in a lot of cases in the on-premise world, when you're seeing an attack develop, you don't want to take action right away, right? You want to watch, and you want to know what the attack pattern is, and you want to see what they're trying to get to, rather than just that they're there. So we use all kinds of tactics to essentially watch the attackers when you find them early enough, and before you shut off their access, right? You try to make sure they can't see you. So like one of the ones that we do on Microsoft now in our labs is all of our machines have screen scraping running on them, right? And so if a machine gets taken over, which isn't that often, but once in a while a machine gets taken over, at least you can then watch and see what the heck is the attacker doing. And you can learn a lot about what are their attack patterns and what tools do they use, what are they after, before you go shut them down, right? Because you want to really understand what's the technique so you can turn off the whole technique. What were they planning to get to so you can go see if how you might secure that ultimate resource they were trying to get to better, right? And learn a whole bunch before you just jump in and close off their access. So it's a cat and mouse game for sure.
I was curious, my question is primarily rooted around the outside access and what you're doing with that data. So you answered both, but I would say my focus is on the outside.
Okay, gotcha.
So I really love the concept of adaptive access control and machine learning and all of that. But one of the biggest problems with machine learning is it has to learn. And so what are you guys doing to combat that learning process from being poisoned? Either in the beginning where it's stupid and it doesn't know what your daily pattern is yet, and preventing a bad actor from coming in and pretending to be you before the system knows that you're you.
Yep.
Or what I think is a more interesting issue is it being subtly poisoned with slight misinformation over time, such that eventually somebody could come and use 35 apps at 11 p.m. and it wouldn't trigger anything.
Yes. Hey, you're talking about the Machine Learning Employment Act. So we could spend hours talking about it, but so you've pointed out the things that really are kind of the interesting challenges, right? Which is, if you're learning, how do you get a clean learn, right? And we have a lot of ideas about how that happens. In fact, for our advanced threat product, we think we have a reasonably clean learn in the first 2 weeks where you don't have to do a lot of tuning. But I'm sure 6 months from now, someone will have figured a way around that. So, hey, we'll get to send out some more algorithms, right? And then, yeah, the most pernicious one is definitely I take over and then I slowly build up to make it look like normal behavior, right? That's a much, much harder one to combat. And we have some ideas around how to do that, but that's certainly the emerging set of attacks I think we're going to have to look out for. Yeah. But yeah, it's just like It's machine learning, hey, what do I do this morning? Oh, right, more stuff to do. Yeah. At the back over there?
I love the piece with the abnormal behavior. I think that's something that a lot of people are looking at. But my question is, as you're sort of building up these entity profiles and building up this sense of normal behavior, it seems like you're kind of building like the holy grail that a hacker wants to steal. So is there a way to do that when you're not really building this really intensely valuable centralized database?
Yeah, so that's a great point. So the first thing to realize, I think, like I try to keep in mind, is that unfortunately your directory is the holy grail, right? Like it's got lots of everything in it. And there's not very much that we're building up that isn't in the directory already. So we haven't changed your risk profile a lot. The other piece we try really hard to do is to make sure that that holy grail isn't visible on the network, right? So for instance, if you're watching your domain controllers, make sure the machine that you're watching from is not domain joined. You know, make sure that it's not active on the network. Like for instance, one of the things we do is we just use the spam port on a machine, right? And so we're trying to get to the point where there's no signature that the collection point even exists, right? And then you have to do all kinds of things about hardening your collection point as well and making sure that it's not it's not more vulnerable than the thing it's protected, that it's watching, right? And that even if it does get attacked, that it's not a valuable piece of infrastructure, right? That everything keeps working the way it should, even if it's under attack, and that you can sense from the outside that there's something weird going on with it. So but the biggest thing for us is just be invisible on the network. Yeah. It's not really my area of expertise. The one interesting thing that a lot of teams at Microsoft are using now is looking at the process chains on a machine, right? And for instance, in our cloud labs, we watch the process chains for a lot of machines as they boot up to look for strange things that shouldn't be there. And you can essentially get a fingerprint of what your process chain on that machine looks like, and then the next time it comes up, check for a different process chain. And using the same kinds of abnormal, you're essentially looking for abnormalities, but differences from the process chain it had yesterday or the last time it rebooted, you better go look at. So that's the best I got. It's not my deep expertise. And I'm getting the crook to get out of here. All right. Thank you for your time. I really appreciate it. And